My name is Ray Durrheim. I'm a professor in the School of Geosciences at the University of the Witwatersrand in Johannesburg. Now, my research area is geophysics. Geophysics is where you bring together the study of the Earth, its size, its shape, what it's made of, how it formed, how mountains are built, how ocean basins are formed, and also using the methods of physics. Those are things such as the Earth's gravity, its magnetism, the way in which electrical currents flow through the Earth, the way in which vibrations move through the Earth, to find out more about it. And the science is used to do things such as find new mineral deposits for energy, or for resources of oil and gas, of metals such as iron and manganese and platinum and gold and coal, and also to study things such as geohazards, things that cause harm to people, such as earthquakes, volcanoes, and landslides. Yes, as you said, I grew up in Cape Town, did all my schooling in Cape Town, and I guess I'm one of those fortunate folk that both had an aptitude for maths and science and languages. So I did, in fact, very well at school, and I also worked fairly hard, but I also enjoyed other aspects of life. I enjoyed playing sport, being involved in student and scholar societies, and so I think I had a fairly well-rounded schooling career. I was privileged to be able to go to a good quality school as well, and have good teachers and good facilities and laboratories there as well. I suppose I grew up in a family. Both my parents came from farming families, and so we'd often, for our holidays, go back to the family farms in the Eastern Cape, and also have many holidays along the beaches or in the mountains. And so it's something I think I also just took to naturally, just enjoying being out of doors, being at the sea, in the mountains, in the rivers, and exploring, looking at plants and animals, and trying to understand more about nature, just both from its sheer beauty and the wonder of it, but also out of a curiosity as to how this works. What are the habits of birds and animals, and what are mountains made of, how were they formed? And so I think there was a natural curiosity, but also opportunities for me to learn more about it by traveling quite extensively around southern Africa on our various family holidays. Well, I was fortunate that way. When I came from a family that were not able to send me or afford to send me to university, so I needed to look for a bursary, and I was fortunate to get a very generous bursary from a mining company that was called General Mining. And even to this day, many mining companies, of course, are looking for skilled practitioners, for geologists, for mining engineers, for geophysicists. So there certainly are bursaries available there in this field over here. And of course, often they look for people, particularly in areas where there are already mines. So for example, in the Limpopo and Mpumalanga provinces, in the Northwest province, these are places where gold and platinum is mined, and also coal. And also the areas like the Eastern Cape, which have historically been labour-sending areas. Many mine workers have come from the Eastern Cape as well. And so often the mining companies will choose students who are keen to follow careers related to mineral exploration and mining from these regions. If you look around the room that you're in, you'll find that all the materials around you are either mined or they are grown. Now you'll see there, of course, bricks and concrete are made from earth materials. If you see the things made out of plastic, well, plastic in fact comes from petrochemicals, from hydrocarbons that come out of the earth. You see motor cars, of course, are made out of steel, and so that comes out of the earth as well. So the earth materials are absolutely crucial to modern society. Even your cell phone is made out of many materials that are mined. The glass, all the special elements that are used to make the transistors and electronics work. So mining is in fact absolutely fundamental for modern society, for the comforts that we enjoy, for the making of roads, for the transmission of communications. All depend on the raw materials. And so mining is in fact a very important contributor to our South African economy as well. We are blessed as a country to have very extensive mineral resources. Many hundreds of thousands of people are in fact employed directly in the mining industry. And then there are many secondary industries that take the products from the earth to turn them into manufactured products. So this is a large source of South Africa's wealth. So mining, yes, it is an important industry, but of course it can be a risky industry because our mines are very deep. Our South African mines, in fact, are the very deepest in the world. And so we have knowledge and skills here which are sought out elsewhere in the world, because as your shallow, easy to find mineral deposits are exhausted, we need to go and mine deeper to extract new resources. And so that's been something that's really drew me to the science of seismology, is to look at the great forces of nature, earthquakes. And our South African mines are like earthquake laboratories. We can do research here that you cannot do elsewhere in the world. We have scientists coming from places like Japan and the United States, where they have a lot more natural earthquakes than we have. But when you're in a place like Japan, you might have many earthquakes, but the earthquakes, you're not sure where the next earthquake will be, when it will happen, and often it's so deep down it's very difficult to instrument. And so we have Japanese scientists coming to our mines because it is our mining process over here that triggers these earthquakes. So we know where we are mining, and we've got a fair idea where the next earthquake will be and almost when it will happen as well. So that allows us to put instruments into these in the mines, study the way in which the earth responds to the mining, see the way in which the elastic forces build up inside the rock. It's a bit like if you imagine if you had to take a plastic ruler and bend it, and you'd see little cracks appearing, but at one stage there are too many cracks and suddenly that plastic ruler will break. It's the same with a rock. Your rock gets damaged and energy is stored up, and then at some stage the rupture occurs, it zips through all that energy that's stored up, makes the ground shake, and that can cause rocks to be ejected, the roof to fall down, and that's a very significant hazard for mine workers in our deep mines. And so a large part of my career has been spent researching these earthquakes that are induced, is the word we use, they're caused by the mining, and what we can do to make them less dangerous. And we do that by changing the way in which we mine, the way in which we cut and break the rock, the way in which we reinforce the rock by putting in bolts and nets and spraying on concrete, and also by monitoring this continuously, and in that way looking for patterns that indicate that there's an increased chance of rock burst happening. And so it's been really gratifying in the course of my 20 or 30 years in working in the mining industry to see the level of safety improving quite dramatically. There was a time 20 or 30 years ago where it was regularly reported on the news that 5 people, 10 people had been killed in a rock burst. Now, fortunately, that is a pretty rare occurrence. So I had a bursary from a mining company, and so when I graduated, I then of course went to work for them. And over those 2 years, I was sent off to many different parts of South Africa. I spent time in the Free State province doing surveys to explore for coal deposits. I also spent time in the Northern Cape near a town called Pofadder, and also in the Limpopo province near a town called Aldays, searching for base metal deposits such as copper and lead and zinc. And I also did work interpreting magnetic surveys, aeromagnetic surveys, to look for gold deposits in the Witwatersrand Basin, an area around the Gauteng province. And so it was pretty interesting, but I found that I was actually got a little bit lonely out in the field. I'd imagined that I would love being out in the bush all the time. And so I kind of reached the conclusion that mineral exploration was perhaps not the career for me. And it was at that time I was chatting to my professor at university, and he said, well, why don't you come and teach here for a while? We're looking for a junior lecturer. And I found that suited me far better. I could still get to the field, but I had more control over where I went and when I went and for how long. And also I enjoyed the stimulation of being on campus, of working with young people, and of discovering new knowledge. And so that worked out as being a very good fit for me. But after about 10 years, I got married, we had children, and also I was ready for a new challenge, I think. And so then I was moved across to the Council for Scientific and Industrial Research, the CSIR. And I spent the next 20 or so years working at the CSIR, and I was in the mining technology division, and there I focused really on mining under extreme conditions. This means at great depths and at high rock temperatures. And I think what had really attracted to me is I felt I was making a real difference in people's lives, because over here at that stage there were many people that would die each year and would be injured as a result of rock bursts. And so I focused on the research related to rock bursting. And as time went by, of course, my responsibilities grew, and I ended up leading a major research program called Deep Mine. And the idea there was to develop the knowledge and technology to make mining possible at ultra depth, at depths between 3.5 and 5 kilometers. And so I was part of a program which I co-led with an American colleague, Andy Nyblade, which we called Africa Array. It was to build capacity, to gain knowledge throughout sub-Saharan Africa. So we set up an observatory network of 50 stations, our backbone stations, which in countries such as Ghana, Nigeria, Ethiopia, Rwanda, Kenya, Tanzania, Malawi, to monitor the whole continent. So we both had seismometers, which are measuring the vibrations in the earth, but also sensors to measure the movement of the continents that could measure movements very accurately of perhaps 1 or 2 millimeters a year to monitor how the continent was moving apart. And we also had weather stations there to look at rainfall and wind and humidity and what we even call space weather, the effect of the cosmic particles that come into the atmosphere. So that's been another major program that I've worked on with colleagues throughout Africa and also from Europe and the United States. And so that's been very interesting. So I've really enjoyed working with students, and I've had students from countries such as Nigeria and Sudan and Malawi and Botswana and Mozambique and Madagascar working with me and researching aspects of their countries and the geology of those areas.
So my name is Obehi Atita. I'm an MSc student at Wits, School of Geosciences. I'm from Nigeria. So in my high school, I was good in the science courses like physics, mathematics, and I think biology and chemistry. From physics, I discovered geophysics, which is the application of physics to study or map the undersurface, which I love. Because it's interesting. It was awesome to actually being able to map under the surface, like the subsurface, and see what is actually happening there.
Now, when I was 13, we were living in Cape Town, and I remember very clearly to this day, it was sometime after 10 o'clock at night when the earth started to shake, and our family, we ran out of doors as did other people, and very soon on the radio and in the newspapers we saw reports of the earthquake, which had happened near the towns of Ceres and Tulbagh, about 90 kilometers from Cape Town. And that's where the damage had been most severe, because many of the dwellings there are not built to be, not reinforced. They were made out of mud brick, and so about 12 people died. But that made a big impact on me, and I suppose I've always found the forces of nature exciting. I enjoy thunderstorms. As a schoolboy living in Cape Town, I learned to surf, and just to be on the waves and surfing with them was something very exciting to me as well. And so, yeah, I think in that sense, for me to be drawn to geology and natural science was a natural thing. It filled my curiosity, and I suppose it wasn't just a sense of wondering about it, but also asking the questions why. Why is that mountain there? Why are the waves sometimes big and sometimes small? Why are there high tides and low tides? I had a curiosity to find out how the world worked. Yeah, here at Wits we have a research group which we call the Wits Integrated Mining Health and Safety Research Group, which I currently am chairing. But these are people who are working on mining, but from different aspects. And so you find that of course there are geoscientists and mining engineers, that's obvious, but you also have mechanical engineers and chemical engineers and metallurgists. But you go further afield, you find people working in public health, looking at occupational disease. You find people working as biologists and looking at ways in which we can prevent pollution and we can remediate areas which have been damaged by mining. We even find people in fields such as law who are involved in this, because we need rules and regulations to govern mining and to issue mineral rights. And you find people even in things such as sociology, because you're working with large workforces. You've got to find out ways in which to, I suppose, motivate people, reward people, make sure that they have a good quality of life. Yeah, I'd say that I'd encourage you to really be curious about things. When you look around you and see a mountain or a river, ask, why is the river there? Why did it choose that course? Why is that mountain there? And in this way, and dig into the internet or look in books, use atlases, learn to read maps. And when you are walking out in the veld, pay attention to the soils, to the rocks that you see, to the vegetation that's growing there, and try to see what sense it and make sense out of it. And that's really the kind of curiosity that we need to be a scientist. I mean, I think for us as earth scientists, we have an incredibly important role to making sure that we preserve our planet for my children, my grandchildren, and for your children as well. And so that involves being responsible in the way in which we mine, in which we dispose of our waste, in which we reduce the amount of carbon dioxide we pump into the atmosphere. And that is a very important role in future for geoscientists, is to be involved in these environmental issues.